we're like a fairly nice-sized crowd, not too big. So I think we can do questions throughout. So if you have any questions on anything as I'm presenting throughout, or something seems confusing, just let me know, and feel free to ask. And I guess my first question is, so I know the M in PANMA stands for marketing. So
Media.
Media.
So close.
I was close. Okay, which is good why I'm asking the question. So I wanted to get a better feel of like what everybody's background in data is. So how many people here work in data or tech? Okay, how many people work in tech? Okay, how many people work in marketing? Okay, cool. So like, so a little bit. And how many people work in something that has nothing to do with any of this, or are just curious to learn about it for the first time? Okay.
You mean in addition?
Or something. Yeah. Okay, cool. So, yeah. So my talk is going to be about sense and sensibility in data science. You might have heard about some stuff that's going on with big data, learning things from data. So I'm here to offer a little bit of a perspective as someone who practices data, as to what that means. So my name is Vicki. You can follow me at Vicki Boykis, and I will post these slides. So a little bit about me. I work at CapTech Consulting, which is a company based here in King of Prussia, and we do a number of different IT consulting things. So if you're interested in any of that, come talk to me afterwards. My personal background is in data science. So I started actually as an economics major, and then I got into data after I graduated. I've been doing data for the last 10 years. If you're in tech, some of these words may look familiar, and if you are in tech, they might not. But I basically have been doing data science with Python and R, both data engineering as well. And then I've worked across a number of industries over the past 10 years. So I've worked in retail, international trade, telecom, healthcare, which is my way of saying I've seen a lot of different industries, and I've seen like the same pattern coming across a lot of different industries, and so that's what I want to talk about today. So before we do that, I want to talk about potatoes. So one of my favorite authors is Douglas Adams, who wrote The Hitchhiker's Guide to the Galaxy. And he wrote a story that was included in that about the scholastic armor fiends of Strigarax. And so the major takeaway from this story, I'm going to come back to this later, but it's a mistake to think you can solve any major problem with potatoes. So a little bit of background on the scholastic armor fiends of Strigarax. They were a very, very violent race who lived hundreds of millions of years ago in another galaxy. They were so violent that they were just always going out and punching people and starting wars. They wanted to kind of stop this because it was really hampering going about their daily lives, like teaching daycares, being dentists or whatever. They would just get in a fight. So what they did was they enacted this rule that before you went out about your day, you had to go and punch a bag of potatoes to take all your aggression out. So this worked for a little bit until it got to the point where one bag wasn't doing it for them. So they had a second bag, and with 2 bags of potatoes, they got so energetic and excited that they got ramped up again to start another war. So they went out and did more wars. They actually invented a computer to blow up the universe. And the computer was so ethically horrified by what they were doing that she said, it was a he said he wouldn't do it, and so they destroyed the computer, which got them even more excited and led to even more warfare. So the basic point of this story is you can't solve a very complicated problem with what is seemingly a simple solution, because it's just going to escalate from there. So keep potatoes in mind as I walk through the rest of this presentation. So the same as the problems that we face within the data industry today. So there's hype data problems that you might read about in the press. And then there's real data problems that people are solving on a day-to-day basis. So I want to talk through what the hype data problems are, what the real problems are that we're dealing with data, and how we're trying to solve those real problems. So there's a lot of stuff going on, and you might have read about this in the media, but there's a couple things that we worry about, but that we really shouldn't be. So the first one is outsourcing of human jobs. So there's a lot of news in the media about how robots and bots and AI are going to outsource all of human knowledge work. The second one is about self-driving cars. So there's a lot of noise, a lot of worry about what the implications of having self-driving cars are going to be, how we're going to regulate them, all of that. And the third one is robots. So what are we really worried about with all three of these things? We're worried that humans are going to be taken out of the loop, and we're going to be at the end of human decision making. We're not going to be involved in the process anymore. So let's walk through them. So the first one is the outsourcing of jobs to technology. So I think this has been building steam over like the last 5-10 years. The first one is a study that was performed in 2013 that said over half of all jobs are going to be automated within 10 to 20 years. Well, we're about 5 years out, so we should be like at least a quarter automated, but we're not really at that point, right? And the second thing was Jeff Hinton, who is one of the fathers of modern AI. He pioneered a concept called neural networks. He basically said that it's quite obvious we should stop training radiologists, because basically machine learning has gotten to a point where it can diagnose diseases better than human radiologists can. So these kinds of things have been popping up all over the news lately. But what's the reality of the situation? The reality is that the hard problems to solve are still very much human-based problems. So for example, in the first case, ironically, that study that I talked about outsourcing, if you look at the methodology of it, it said that we develop a novel methodology to categorize. So they basically had to figure out a way to categorize the jobs they were going to study and then forecast how many of them would be depleted. But they had to do that themselves. Computers couldn't do that for them. And then they had to implement or run that code to estimate the probability of computerization. So they were still behind that study, even though computers were doing the work of crunching through the numbers. And then the second example with the radiology. So there was a really big news item last December, I want to say, about this data set called the chest X-ray 14 data set. It's a data set that's used a lot in medical diagnostics. So basically what you have is you have a bunch of images of X-rays, and then by the image it'll say this was the diagnosis that a doctor gave. So you feed all those X-rays into a predictive algorithm, and then you can train the algorithm to predict other X-rays that you don't know anything about. So there were huge problems that were found with this data set, and basically a radiology student went through and saw if the labels on the X-rays were correct, and a lot of them were not. So ultimately, it still comes down to people having to create these labels for these data sets. So at the end, you still have human judgment that you need to invoke. So the second one is about self-driving cars. So Elon Musk is obviously all over this. He said 2 years ago, we're 2 years away from sleeping in our cars. So by his prediction, we should at least be napping in them or like lying down or something, right? We're not anywhere close to that point yet. There's a lot of articles about how autonomous cars are going to change everything, how they're going to change the ways that cities are built, how they're going to change how much leisure time we have, all of that stuff. So that's obviously not the reality. And the reason it's not the reality is because we still don't have enough data for cars to be accurate. So remember how I said that X-rays need to be labeled so that computers can learn from them? Self-driving cars need the same kind of training data. And so neural networks is the machine learning algorithm mostly responsible for self-driving cars. And training a neural network takes a lot of time, because if you think about it, so the car is driving, it takes video of the road. Each video is a screenshot in time, and so you feed it, it has to feed that screenshot back real time into the algorithm and process everything it's seeing. So it has to say, I'm at an intersection, what should I do? I'm at an intersection, there's another car, what should I do? And so all of that has to happen, and it has to have rules for each one of those things. So even for a not super complicated neural net on really, really fast GPUs, it takes about 51 days. Well, 51 days, I'm sorry, is for this simple one. It would take about a year to actually train an accurate one. So it takes a really long time to basically rebuild reality. The other thing is that, again, humans still need to be in the loop for this kind of stuff. So in addition to the algorithms being trained automatically, what you have is you literally have people that are annotating what a pedestrian is, what a car is, what other details are. If you've ever seen, when you have to log into a website, like if you see the Google CAPTCHA that makes you tag the images, that's what you're doing. You're basically contributing to their image recognition training set. like this is a street sign, this is a storefront, this is a car, this is a person. So all of that still ultimately at the end of it needs to be people driven. And the third thing we're worried about is obviously robots. They're gonna kill us soon, right? That's actually what I thought when I saw this picture of Jeff with his dog. It was pretty terrifying. But that's not true because AGI, artificial general intelligence, which is how robots think and operate and make decisions, it's still a long time away. And if you want proof of that, just Google robots playing soccer, which is the video that this is from. Every year there's like a competition of robots that play soccer together. And it's basically like just like 10 minutes of them falling over. Like not even getting to the ball, just walking a foot and then falling over because they can't detect a rise in the surface. So we still have a very long way to go to even start to think about AGI. So don't worry, not there yet. So those are the 3 problems that the media has us thinking are the problems in data. What are the real problems? So one is right now moving data into the cloud, and the cloud is just somebody else's computer, right? So everybody is moving their data from their own servers to somebody else's server. Second is security and data privacy, and third is interpreting model intent. Yep.
Before you transition into this, so you were saying that we shouldn't worry, but can you like predict a timeline that we should worry that those things are going to happen? You worry now.
Just in case, right?
Just in case.
For AGI, I would say at least 50 years. Self-driving cars, I would say 25 years. Again, I'm just some random person on the internet, so I'm not an expert, but just based on what I'm seeing, like I would say that that's the case.
Thank you.
Yeah. This stuff is real though. And the third one is model intent, which is interpreting what your machine learning algorithm is actually doing and what it's spitting out. So again, on the hierarchy of things to worry about, robots will kill us is not a worry because we're not even there yet. So this is all the stuff that has to happen. So maybe this will help you envision timeline. This is all the stuff that has to happen before robots kill us. So first of all, we have to make sure that all of our data, so an S3 bucket is a way to store data in the cloud, on Amazon's cloud service. We have to make sure that all of our data can be in the cloud and can receive that training data. And not expose our company's robot secrets while we're doing it. Second of all, we have to make sure that all of our robot training data is clean. Cleaning data takes up 80% of any data professional's work at any given point in time. So by the time we clean that, maybe we'll get there. Third, we have to make sure that our robot experiments are in compliance with GDPR's rights for machines, which I'm sure there will be in 50 years or whenever we get to that threshold. Fourth, robots are going to plot to kill us, but they're going to fail because there's time zone issues. If you write code, you know there's always time zone issues and time zone conversion issues. So we have to get past that issue. And then finally, robots are going to kill us. By the time they come for us, we'll be ready because this is going to take a long time to get there. So we're really still here.
What's an S3 bucket?
An S3 bucket is the way to store data in the cloud.
Oh, okay.
Think of it as just like a directory on somebody else's server. Just like a file
like an
folder on
FTP
somebody
directory?
else. Yeah, exactly.
Okay.
Yep. So the way I wanted to show kind of where we are and like what kind of problems companies could actually face is to walk you through a case study. I have an MBA, so case studies are like the language that I speak in. So I decided to go for book retailer because I like books. Let's say you're a large traditional book retailer. You've been doing well in brick and mortar sales, and you're okay on your website, but now you need to compete against Jeff and his robot. So this is kind of like the business problem that you're looking at. What are you gonna do? So as an example, this is kind of what your website looks like. So it has books that you can look at, you can check them out, you can add them to your cart, just like a simple, nice site, nothing fancy. But what you want to do, this is a little bit more technical, but basically you have a database and then you have the front part of the application that users talk to. So a database is where companies store everything. So let's say you put in your address somewhere into a form on the internet. It goes into the database. Let's say you purchase something. All those purchases go into a database. So you have the database, and then you have your front-facing application. And that's the part that people click on the UI. So then your boss, usually it's the CEO or CTO, they read a paper on deep learning. And they have seen that YouTube uses deep neural networks for YouTube recommendations to serve you accurate recommendations. And they say, we want to do that because we want to be as good as YouTube. Never mind the fact that YouTube has billions of users and billions of rows of data. And you're just like a middle book retailer. They want to do deep learning. And deep learning, by the way, is a subset of machine learning, which is all a subset of AI. So you decide, you do some thinking, and you decide to create Harry Potter, which is an AI-based sorting hat for your book preferences. So your product manager comes up with this, and they also come up with a graphic, like to really incentivize people in the company to work on the project. And so what it really is you're going to have a sidebar that gives you recommendations of stuff that you also enjoy based on the book that you purchased. So what does it take to actually get this sidebar into your web application, is the question, into your website? You're going to have something like this. So just as a refresher, this is kind of what the back-end architecture or how your software looks like now. If you want to add that, you're going to have something that looks like this. Because now you have databases, you want to send that data to the cloud, you want to do predictions and analytics on that data, and you want to make sure that there's quality checks. So your website now gets a lot more complicated, and all of these steps have to work together just for a simple recommendations algorithm. And so what you're offering ultimately is a scalable cloud-based application that interfaces with your existing web app to offer personalized recommendations using neural nets. That's what your CTO is going to tell you. Your old problem was that you couldn't compete with Amazon. But your new problem is that you now have 3 new things to think about. 1, you have to think about how you're going to move all this data to the cloud. Whenever you move data, there's always a security risk. So you're going to have to think about that. 2, you're going to have to think about data privacy, how you manage that data, make sure you don't expose anybody's book recommendations or purchases. And 3, you're going to have to think about, well, let's say the recommendation model was wrong. What does it mean that it was wrong? Why did it offer me the wrong book? Or why did it serve me the right book? Like, what's the reasoning behind your model? So now you have a lot more different things to think about. And it gets a lot more complicated.
When you speak of model interpretability, is that where you try to figure out how the AI came to that recommendation? So it's good debugging.
Yep, that's right. Yeah, you want to try to figure out how the algorithm did what it did. So the first one is moving data to the cloud. So this is a big thing in a lot of companies right now. A lot of companies are moving their data to the cloud because it's easier to manage once the data gets there. You as a company are not responsible for certain aspects anymore, but you have to move it. So it takes like 15 months or so from the start of moving something to actually starting to get data. You have to plan out all those environments. You have to allocate the budget. There's a lot of stuff that has to go on: stakeholder buy-in, migrations, estimating costs. And the big one is right now finding cloud-native talent. So a lot of people talk about doing stuff in the cloud. It's really hard to find people who already have experience with that and know what to look for in that area. So that's one thing that you have to think about. So for example, this is like a technical explanation of what needs to happen. So you have a database and you're trying to move it to the cloud. But you also want to think about, again, cloud-native stuff. So you have to find people that know how to do stuff in the cloud. You have to allow end users to be able to manage all of that data as well. So that's another layer of complexity. And then you have to increase cloud literacy across your organization. So that's another thing that's happening right now. The second part is data security and privacy. So this is something that's big in the news that really is important. So what a lot of people are finding is just because they put their data in the cloud doesn't mean it's secure or safe. You have to guarantee that. And so the S3 buckets that I talked about before, that directory of files on somebody else's computer, that's not locked down until you lock it down. And people find that out the hard way because, for example, Alteryx revealed the financial info of 123 million American households just by having that directory out in the open. There was a data bank of voter records that was leaked, I think from both parties actually recently, that was also in open buckets. The Equifax data breach, which didn't have to do with that, it had to do with a software upgrade. But still, basically I assume that basically my data has been resold at least like 10 to 15 times at this point. And so that's something that you want to think about as a company. And then the other thing that's coming down or has come down the pike is GDPR. You probably got like a slew of privacy updates 3 to 4 months ago. Every company was like, we've updated our privacy policy, we've updated our privacy policy, because they now have to comply with GDPR. And so what that means is they have to store your data in a very secure way. So that's another headache that they're dealing with at this point. So here, if you're moving data to the cloud for Harry Potter, you wouldn't want to have it compromised. So some things you want to think about are the less data you store, the easier it can be. And that's kind of contradictory because in order to create an accurate model, you need a lot of data. So for example, for the self-driving car, you need to have a lot of cases of this is what a stop sign looks like during the day, this is what it looks like at evening, at night. Here's what a stop sign looks like tilted, right? So the more data you have on that, the more accurate it will be. But you can also keep windows of history for your predictive modeling depending on your case. The second thing that people are using right now a lot is something called differential privacy and synthetic data creation. And this is something that Apple does a lot of. So differential privacy means adding noise to user patterns so that it looks like you, but it's not exactly you. So for example, they might scramble your age, or they might scramble your name, basically just enough to still be accurate, but not necessarily to, if they got hacked, that it would give away that it was you that did a certain thing. And the third problem is this problem of having neural nets make decisions like people, or any model. And so that comes to interpretability and being able to understand why models act the way they do. So a good example, a local example of this is the Barnes Foundation. So if you've been to their website recently, you know that they have a really beautiful collection of art that you can just kind of browse through. They redid this maybe a year ago. And if you and it's all the art in their collections. If you click on a painting, it'll take you to a different painting, and you can look at everything. So what you can do is you can look on paintings that are more like this or less like this. And so what they found was because you were clicking on certain paintings, they were giving you things that were very similar. So in this example, they were showing you things that were almost similar, so you never found any other artists. So they actually had to manually tweak that. And the second thing is, again, with self-driving cars. So there was an accident a couple months ago in Arizona that killed a person that was crossing the road at nighttime. There was an NSTF safety report afterwards that basically said that the car tried to classify it as a person. So the car started here. The person was like over there. So the car started here trying to classify it. It's like maybe it's an object, maybe it's a stop sign, maybe it's this, maybe it's that. By the time it got to the actual person, it was this close before it actually classified it as certain. So machines are still not great at classifying things, and so what complicated this was it was nighttime and the person had a bike with them. So we still can't account for all the use cases that our human brain can. And so what might happen in our Harry Potter model is that the model only recommends books in the same genre. For example, you pick a science fiction book, it only recommends science fiction books to you, or only fantasy. And you won't be able to figure out what's going on. So the solution to that is to get people involved early in the process, which is something I've been talking about the whole time. Make sure that you have people testing the model, make sure that you have data validation, collect a lot of different data, and use models that are easier to interpret. So again, it's a mistake to think you can solve any major problem with just potatoes being machine learning and AI in this case. And that's it. So that's something I would challenge you to think about at work. And let me know if you have any questions. Yeah.
This is maybe a little trivial. When you do the reCAPTCHA and it says, show me the streets, click the street signs.
Yeah.
There'll be the majority of a street sign in a square and a little corner of the street sign. Does it think the little corner is a street sign?
I don't know. That's the thing, right? We also don't know what these models are thinking. Like when we as consumers use stuff like the Facebook newsfeed or Twitter or go to reCAPTCHA, there's no way to see what's going on behind that. And I think that's as much of a concern as robots or anything else. Yeah. Yep, go ahead.
So I work for a small management consulting firm. You said it would be about 15 months to move data into the cloud. Is that presuming a given size? I'm trying to figure out if that's effective. For
So this was a study that was done on, let me go back, if I can find it. 15 months from initialization phase to 80% of a budget being cloud spending is the actual term for it. And I'm happy to share the link if you're interested. But it's going to depend a lot on organizational size and data. And I think actually even more organizational size and how complicated the data moving into the cloud is. But I would say like if it's a small startup with 3 people, you're going to have stuff stood up in 3 months. If it's an organization where you have to get people to sign off on stuff, it could take easily a year or more. Yeah.
Yeah, I could second that. The last place I was working, they were trying to do that. And it was even a year before they even made a decision to even start doing anything.
Yeah.
Mhm.
The place I'm at now started 2017, and they're making a goal 2020. So
To move to the cloud.
yeah,
That's really interesting.
so that's
Yeah.
pretty accurate. I have a very in the weeds question about glue,
Okay.
but I could wait.
Feel free to chat with me afterwards. Yep.
When you were talking about the self-driving cars
Yes.
that were having to figure out what everything was, can't they do that ahead of time? Doesn't Google have a picture of everything on every road? I mean, can't they teach it that before it gets onto the road, or did they?
So that's what they were doing. So, well, I can't speak to the intricacies, but from my understanding, so the trained model is what actually teaches everything, but then it has to also identify different things at different times.
Mhm.
So it might be reaching to the Google server, it might be reaching into the model. Either way, it has to go somewhere and recall that image, which might be like seconds or milliseconds of time that you don't have. Yeah.
I believe you that the robots are not about to kill us, but I'm actually more concerned with the use of it by people who believe that the ability of AI and machine learning to predict certain things in the social sphere excuse me, is good enough to use to the horror model I have in mind is Minority Report with for anybody's not familiar with it, it was a presumed a future in which you could predict who was going to commit a crime and lock them up or shoot them before they did it, so be safe. And while that was science fiction, some things I didn't think people would do, they're doing. So, do we have any examples where this sort of very powerful intelligence is being misapplied because someone thinks it can do something that it simply cannot reliably do?
Yeah, all the time. A lot of the stuff that the big companies, the big social companies, Facebook and Google do is kind of an example of that. And this is not really AI specific, but the incident with Chrome last week. So basically Chrome, the browser, is trying to get you to force log in as you start browsing, so it keeps all of your browsing history then for use in further Google products. So that's not AI specific, but it's an example of decisions that companies make that are not necessarily malicious, but are tied to their business model. So it's in their business model incentive to collect data and to analyze you. And so as a result of that, there might be some good things that happen, and there might be some things that are not so great. Yep.
How much of, with work that you do, see companies trying to solve the wrong problem with data? I think the example of self-driving cars. Like if you want less cars on the road, more safety, the answer isn't self-driving cars, it's public transportation.
Right.
So how often do you see that in a consulting framework where people are just trying to throw buzzwords with big data and trying to solve problems that can be more easily solved with something that already exists?
Yeah, I think that's definitely a concern, and it's true across all industries. It's not specific to any one thing. But what I usually see if I come into a company is they'll try to say, well, we want to do machine learning. And what they actually mean is we have this specific business problem. So as a consultant, my job is to get to that actual business problem and try to figure out why they're doing X or Y. So for example, I had a company a couple years ago that was trying to do neural nets. What they really wanted to do is better understand their customer segments, which we had to work backwards to figure that out before we did any work. So a lot of time, like the first month or so, we'll be trying to figure out what the actual problem is. So we don't waste time like doing all this stuff if we don't need to. Yeah.
I don't want to hog the floor here, but on the other side, do we have any examples, real world or about to happen, of the highly beneficial use of this technology?
Yep, so actually, I was getting sick of reading all the negative stuff in the news because I'm super pessimistic, so I read all this stuff all the time. So I actually made like a little notepad for myself called Wholesome Machine Learning to prove like the positive cases of it. And so one thing, the city of Boston actually used it to reduce their rat population. So they created an app that you could text in if you saw a rat, and it was like a really simple number that you could dial. And so then they created a map of where the rat populations were, and they correlated with different things like a lot of restaurants or trash cans or whatever. And so they were able to reduce rats by like studying the patterns of rats in the city. So that's not like a really sexy case of machine learning, but I think it was a great example of doing public good.
I'm trying to get my head around this. I have a database background, and I also know about data warehousing, but this doesn't seem to be that, and I thought this was going to be more about that. How is this data stored? Is it in relational databases, or is it some kind of like, we in the old days had Prolog. I don't know much about AI. So how is this data stored, and what's the architecture?
Yep, so going back to, and I'm happy to talk with you more in detail afterwards. But basically you have a...
Right, Postgres is a relational database,
Yep.
and so is Oracle.
So you're moving it, usually stuff in the cloud, when you move it in, you store it in a key value store, which
Okay.
is,
I wasn't really clear on why you would have to do that, but okay. But I believe you.
You wouldn't have to, but a lot of companies do this because they want to scale. So for example, if you want your store to compete with Amazon,
Right.
you're going to have your data have to be really fast.
Yeah, right,
I
okay.
know.
In other words, it can't be on one server because
Correct.
it's not fast enough.
Correct, yeah.
Yeah, okay. All right,
Yeah, happy to talk more afterwards.
okay, yeah.
Yeah.
So, I don't know, I started off with enlightening. So the Facebook machines that came up with their own language, what was the fear that made them pull the plug if we're that far away from robots coming to solve?
Okay, so that was a mischaracterized news article, and if you can't tell by now, I really hate the way the general press covers AI and machine learning. But basically what happened was they didn't invent their own language, but they were getting good at predicting the next word. But the language, they weren't really talking, like, it didn't make sense. It was just their own language in the sense that, like, they knew that the word orange came after the word that, and that meant something to the machine. But basically what it meant was that it had a lot of garbage input. And so they pulled the plug because they got a lot of bad press, but not because it was necessarily going anywhere.
Okay.
I can send you a link to more info about that. I can post that afterwards. Yeah.
What techniques are they using for data integrity? Because the example of the Uber car killing somebody was on a clear night. What would have happened if it had been snowing?
Exactly. Yeah. So that's why this stuff is really hard, right? So the data integrity is the model itself, but the model is essentially a black box. So you know it identified a person, but you don't know how or why it did that. You just feed it a lot of different stuff, and it says this is a person. So it's kind of like the human brain. It's not exactly the same, but it's kind of like the human brain in that if we see a box of pizza, we know that it's pizza, but we don't know necessarily why we categorize it that way. It's probably based on the fact that we saw a lot of boxes of pizza before. So the bottom line is data integrity is very hard to validate on that kind of data.
Have any techniques been recently developed to assist in that process?
A lot of it involves creating a training and test data set. So they'll train the model, and then they'll run the model, and they'll compare it to data that they already know the answer for, and they'll see if the model accurately predicted it. And that's how you can test whether a model is accurate.
How do you go, oh, sorry,
No.
you had your hand up first.
Okay. Yeah, I understand that the most powerful AI method that is used right now is forward learning.
What is it?
Forward learning. It's called forward learning.
I haven't.
Forward learning. Forward learning.
Forward learning?
Yeah,
Oh.
forward learning.
Okay.
That means let's say you want an AI to predict an environment. So if it goes around, then it will be going forward and predicting that environment as it is. However, if you put something unexpectedly, like for example, you bring an elephant in the room here, then to be confused because you cannot go back and do the prediction of whatever it has seen before. Yeah, so that said, I understand on the AI section, but what do you think? What is stopping? What is putting the ceiling in the progress if the deep learning and the AI and the other methods are already under control? What is the real thing that is putting a ceiling to the progress?
I think ultimately we just don't have enough data to model our world, right? So prediction is all about modeling on past things. And so there's a really good book about this called Black Swan by Taleb, if you've read it. So it basically says humans are really bad at predicting outliers in general, which is why no one predicted the Great Recession coming. And so I think that's a problem across all machine learning, economic forecasting, anything where we have to forecast stuff, which is pretty much a lot of stuff in machine learning. Humans are really bad at that, and a lot of it is because we just can't, and some of it is because we don't have enough data, in my opinion.
We don't have enough data, or we have too much data?
We have too much data, we don't have enough good data.
Well, it's also data changes on a nearly immediate basis. For example, the self-driving car question that he had earlier, the first thing I thought of is, well, if there's construction, that can happen in an instant, and that kind of stuff, Google can't know that on its maps. It takes it a little while for that stuff. Even Waze, Waze can report it, but, it's still not fast enough.
Yep.
So somebody will drive right through it.
Are we getting any better at the application of these technologies to epidemiology, global epidemiology and weather prediction?
That I cannot speak to. I'm not an expert in either field.
I can talk a little bit about that, actually.
Oh, yeah.
I work in public health, for anyone who doesn't know me, specifically in HIV. And the city recently was funded for molecular surveillance grant for predicting HIV clusters. So there's a lot of work being done there, but it's all relatively new. It's a demonstration project. It's not like a regular thing that the CDC is funding it. But it's called DEXIS. I can't remember what it is right now. So there is some stuff happening with that, with communicable diseases mostly.
I have a quick question about that. Doesn't the CDC just lost a lot of funding for its predictive modeling in as far as Ebola and stuff?
CDC loses a lot of money all the time. Yeah, I mean, in terms of certain, it's always fluctuating for different disease areas. For Ebola, that sounds about right.
And I have a question for Vicki. As far as a lot of what we're talking about is data quality.
Yeah.
And I remember working in a financial tech firm and I was doing something and it was throwing errors because they had trades at future dates. And I was like, but how could you have traded something in the future? And it was because their data was broken. How do you advise companies as far as not just using the data they have, but making it a value proposition to clean the data they get?
So usually, so companies actually have been asking for this by default, and especially larger companies, like they want the metadata management solutions because that's usually how they operate, and because there's like a risk component if they don't have that. So a lot of clients will come to us and ask us to build something that checks all of the data that they put in the cloud or their database or whatever, and make sure that like people can monitor those processes. So I think that's something that companies are thinking about. They might not be implementing everywhere, but it's certainly something that larger companies at least have been asking for.
And that's sort of like a lineage of the data.
Yeah, and that's like a legal incentive for them to ask for it.
What's that? What's illegal?
A legal incentive.
Oh.
Like they might get sued if the data is wrong or bad or missing.
Oh, okay.
Or they delete it by accident.
Right.
Yep.
Is there a baseline interoperability, either like mandated, or the companies strive for when building models, or are they just content if they see like the results they want coming out of a model, not really understanding?
What do you mean by interoperability?
Or I guess like being able to understand how a model works and does what it does.
Yeah. So that was the interpretability piece that I was talking about. So companies want that, and it's. I would say it depends almost. Like if the result is right, no one's going to question it, obviously. But you want to be able to explain your model, because usually when we build models, we build them with developers, but we present them to executives, and you want to be able to clearly explain like why this model is saving money or why this model is making recommendations for these people. Yeah. So that's something that we definitely, and I personally definitely think about all the time, like how to explain all this complicated stuff to people who are not as close to the topic. Okay.
One last one. What are you excited about right now?
Like in the world? Or machine learning?
I was thinking something related to machine learning, but if you're excited about something else, I'm sure I'll be happy to hear about it.
I think what I'm excited about is the fact that all this stuff is being democratized a bit more. So like the fact that it's in the press is making people a little more interested and more literate in it. And I think like the more people are into it, the more standardized and less like hand wavy and black boxy it'll become. Because we're like really in the wild west of machine learning and data science, whatever at this point. So the more people that make it a formalized thing, like the more we can put controls on it, the more we can have formalized process for doing things, all of that stuff. So, yeah.
Well, that makes me think. Do you see any political foolishness with people getting excited about the wrong thing, or misapplied fear, making it? Do you see anything in the way of legislation or fear mongering in politics that might interfere with people's gaining actual knowledge?
I think so. It's been interesting because we're at this point where it's obvious that we need to do something about companies like Google and Facebook and the like, but it's not clear what, because we've never really been in this arena before. So there's been some bills introduced to try to legislate data mining. I think this is coming out of like Hawaii or Alaska recently, which I am in theory for, but knowing that it's probably been led by politicians as opposed to technologists who understand it completely, I'm a little hesitant about it.
Yes. It seems.
Have there been any advances for data recovery after a crash?
Data recovery in a crash. It's pretty broad. Are you talking about something specific, or like on a personal
Talking
computer?
about
or-
going to the cloud.
Yeah.
Most of the databases are relational databases, and they really don't have a algorithm for recovering data.
So one of the good things about the cloud is you can do redundancy pretty cheaply. So like S3, as I was talking about earlier, that distributed key value store, you can store stuff for fractions of a penny. So you can have like 3, 4, 5 copies of your data. And then a lot of distributed systems like Hadoop and Spark, etc., will also automatically keep at least 3 or 4 copies of your data. That's actually one of the reasons why it's so hard to delete something. Like, for example, there's been a lot of swirl around deleting Facebook profiles. When you delete it, you can't actually delete it because the data is at like 4, 5, 6, 7 different copies on Facebook servers, and it takes a while to overwrite stuff. So that's both like a good and a bad.
But that's for for the general public. What do you think about Siri, Alexa, and other one in terms of data?
What they collect, or how good they are, or what the promises are?
Yes, what they collect, what the promises, and privacy infringement.
So privacy-wise, they're not great, because you basically have like a speaker in your house that's on that you can't really tell it's on. Again, this is my own personal opinion. I think for business, there's a lot of potential use, and we're seeing a lot of companies like hotels are using them a lot. So for example, if you want to ask for something, a lot of hotels are getting apps that are related to Siri or Alexa that you can use them for. So I think there's both a personal cautiousness and a huge business potential, to be honest. Yep.
I'm sorry if somebody, or you've already addressed this question, I came in late. But I know that AI is being picked up a lot here for HR, human resources. And, part of my concern is that the way that it is perhaps being employed now is as the initial gatekeeper, which means a lot of people are being screened out, maybe prematurely before they should be, based on a criteria or a keyword that doesn't show up in their resume. But if they were talking or speaking with a person, that perhaps the person would know to ask the follow-up question. And so what do you think about how AI is being projected to be used, particularly among corporations? Because I find that's who's employing it now. How good is it? And should it ever replace the HR function of people actually interviewing who they want to work with, as opposed to letting the machine pick your team?
Yeah, so, I think that's always been a problem, right? Like, we always have to when you apply for a job, you have to put your resume through some awful app that, like, grinds through it, screens for keywords, and then you get a call from the recruiter, right? That might be being replaced by AI, but it was always the case that there's always, like, a level, unfortunately, of gatekeeping before your resume gets to an actual person, unless you know somebody at the company, and then you can bypass that. So actually, it's interesting. So I think the problem is both getting worse and better. So worse because now it's more advanced. It can filter for more than just keywords. And better because there's actually companies out there that are going and making sure that applications that don't necessarily have those keywords go through. So there's a company called Text.io that basically goes through the job application itself, and it looks for any wording that might be hostile or off-putting or like gatekeeping for candidates, and it has companies reword it based on that. So there's kind of like two directions going on. Yeah.
As someone who's like trying to get started in the data field, do you have any like tips for the lessons you learned when you were just getting started?
One would be to learn SQL. That's the absolute base floor. The second is, I don't know, Learn SQL is probably my first one. The second is a lot of people who get into data, like try to get data science positions right away. And I would say actually the place to start is not that, because there's a lot of competition there. It's to kind of make your way around and through all parts of the company in any tech position, so that you can learn about a lot of different stuff and then apply that expertise to data. So my suggestions.
I had a similar question, but more specific to data engineering. Like if you were talking to someone who started a position as a data engineer, it's a relatively new job for them, what would you recommend? Let's say they know SQL, but maybe next steps.
Learning a program probably would be the next one. You can come talk to me afterwards. I'm
Yeah.
happy to like go into one-on-one.
Great, thank you.